Welcome back. In this lesson, I will be doing what we call rationalizing the denominator. Now, this is done because we are not allowed to have a radical sitting in the denominator of our fractions. So we have to take care of that. Observe as I do these examples. First example, I will do square root of 2 over the square root of 7. Now, my goal is to figure out a number that is a perfect square that has 7 as a factor. Now, the smallest of my perfect squares, which are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, and they keep going. Now, the smallest perfect square that 7 is a factor of is 49. So I'm going to multiply the bottom of this by 7. Now, if I multiply the bottom of a fraction by something, I got to do that to the top. Now, I'm going to multiply my numbers under the radical. 2 times 7 gives me 14. 7 times 7 gives me 49, which is the number that I picked from my list. Now, square root of 14 will not simplify, so I will leave that the same. But, notice on the bottom, square root of 49 equals 7. Now, something you got to know. This does not simplify because numbers under radicals do not simplify with numbers that are not under radicals. Next example. Square root of 1/5. It's a fraction, but the fraction applies to both the top of the fraction and the radical applies to the bottom of the fraction. So I rewrite this as square root of 1 over square root of 5. Now, the smallest perfect square that 5 is a factor of is 25. So, to make that happen, I multiply bottom and top by the square root of 5. Well, square root of 1 times square root of 5 is square root of 5. Now, I'm going to shortcut the bottom because up here we've seen that a radical times itself gives me that number. So the square root of 5 times the square root of 5 is the square root of 25. Square root of 25 is 5. So once again, a radical times itself gives me that number. Next example. 3 over the square root of 8x. Now, you could multiply the top and bottom by the square root of 8x, but there's an easier way to do this that will save me some simplifying in the end. What I want to do is find the smallest perfect square that 8 is a factor of, and that is 16. So I need to multiply this by a 2, since 2 times 8 gives me 16. Now, notice I got an x under here. When I got an index of 2, that means I need at least 2 x's under here for them to come out. So I need to multiply by another x. Now, what I do to the bottom, I got to do to the top. Well, on top, 3 times square root of 2x is 3 square root of 2x. On the bottom, square root of 8x times square root of 2x gives me square root of 16x squared. Well, I cannot do nothing on my top at the moment, so that's going to stay 3 square root of 2x. But look at the bottom. 16 square root of 16 is 4. And I got an x squared. 2 goes into 2 one time, so my x comes out. So notice this does not simplify because anything under a radical does not simplify with anything outside of the radical. Next example. Three over the cube root of 2. Now y'all, since this one is a cube root, I want to find the smallest cube. My cubes are 1, 8, 27, 64, 125. Notice these numbers: 1 times 1 times 1, 2 times 2 times 2, 3 times 3 times 3, 4 times 4 times 4, 5 times 5 times 5, 6 times 6 times 6, and 7 times 7 times 7. I think that's plenty for this example. Now, the smallest perfect cube that 2 is a factor of is 8. So, what number do I multiply 2 by to get 8? That is 4. So, y'all, I multiply the top and bottom by the cube root of 4. Now, let's see. Outside times outside. Well, that's 3 times 1 is 3. Cube roots of 4. Now, on bottom, I got a cube root. 2 times 4 is 8. Now, can't do nothing on top. 4 is a perfect square, but y'all, it is not a perfect cube, so it stays under the radical. But I know the cube root of 8, and that is 2. Since 2 is the number times itself 3 times, that gives me 8. And that is our final answer. Alright, so I wanted you to see that when there was a single term on bottom, there are ways to take care of these rather easily. Until next time, goodbye.